Hi everyone, and welcome to the next edition of our IT Tech Talks. Today's talk is part 2 of Git monitoring tricks for all your NICs, where we'll dive deeper into our TA for Unix and Linux. Great, let's jump right in. My name is Caitlin, and I am a product marketing manager here at Splunk, where I focus on our IT solutions. Joining me today is my colleague Robert, who will be presenting on our topic today, the TA for Unix and Linux. With that, I'll pass it to you, Robert.
Thanks, Caitlin. Hello, everyone. My name is Robert Gustafson. Welcome to the Splunk IT webinar series. During our last talk, we went over how the Splunk add-on for Unix and Linux facilitates collecting data from your Linux host. Data like performance statistics, system configurations, and system logging. Today, we'll recap the importance of collecting data from your Linux host and what content is included in the TA. From there, we'll look at tuning the inputs to best suit your environment, how to search the data, building custom visualizations, and creating alerts. Also, our team will be available for Q&A throughout the webinar using the Q&A feature. Today, we will pick up from where we left off last time. The TA has been installed and collecting data like CPU, disk, and memory information from my Splunk server. Today, I'm going to tune those inputs to make sure I'm not over or under collecting any data. Next, I'm going to recap how to search the data, and once we've found what we're looking for, how to create visualizations and alerts from it. But before we get going, let's recap from last time the importance of bringing in data from your Linux host. Hopefully, after watching part 1 of this webinar series, it's clear how important and useful OS-level data from your Linux host can be. Let's quickly recap some of the benefits. Whether you're managing bare metal infrastructure or virtual environments, it's important to make sure your hardware is properly provisioned. Under-provisioned hosts can lead to outages, and over-provisioned hosts can end up costing extra money. Collecting and analyzing performance statistics like CPU, network, disk, and memory can help you find the perfect balance of resources to run your business. Also, keeping an eye on your Linux host's performance statistics and configuration changes can help keep your environment running optimally. Anytime a change is introduced into your environment, it can be an opportunity for things to go wrong. Performance statistics can be used to baseline your environment before and after changes are implemented. And monitoring changes to system configuration can be the first indication that a new setting is causing problems. Collecting this data allows you to measure the effects of the changes and then act if things do not look right. Hopefully, collecting data from your Linux hosts will add clarity to what is occurring with your environment, and then use that information to act in the best way possible to keep your environment running optimally. Last time, we covered what and how the TA collects from your Linux host. To recap, the TA collects performance statistics by running various shell scripts and built-in Unix commands that you might already be familiar with. These scripts are executed by the Splunk forwarder and configured in your inputs.conf as a scripted input. So things like df.sh to pull disk information, cpu.sh to collect CPU statistics, top.sh to collect memory and process information, and bandwidth.sh to collect network statistics. Beyond the performance statistics, the TA also monitors the etc directories for changes to system configurations and the varlog subdirectories for system-level logging. For more information about the included inputs, visit the Splunk add-on for Unix and Linux section on docs.splunk.com. We also reviewed the included knowledge objects that ship with the TA. Most importantly, the TA comes with source types associated with each input. A majority of the included source types adhere to the Splunk Information Model, or SIM. SIM is a standard to normalize your data across multiple source types, facilitating report generation, correlation searches, dashboards, etc., to give you a unified view of your data domain. And finally, the last point to review is how to configure the TA. The TA comes with a Splunk dashboard to assist in configuring your inputs. The dashboard has a button to enable or disable each file input or scripted input. And for the scripted input, it comes with a box to configure the interval of collection. Default values for the scripted inputs represent a suggested interval by type. So next, we'll jump over to my Splunk server and discuss how to change the default collection interval and tune the TA to best fit your specific requirements.
So let's jump back into our TA and look at changing the default collection intervals for our scripted inputs. So from the app dropdown, let's select the Splunk add-on for Unix and Linux, and we'll be presented with the configuration screen. So recall from last time that at the top of the configuration screen, we have our file and directory inputs to enable inputs for things like the etc directory to grab system level configuration changes, bar log directory to collect system level logging, etc. And on the bottom here, we have our scripted inputs that utilize the Unix commands to collect performance statistics. So last time we had enabled CPU, DF, top to collect process, memory, disk, and CPU data. And let's just remember that any inputs we enable on this screen are made local to this particular Splunk server. So once we click save, the TA will start running those scripts on this particular Splunk host. So let's actually take a step back and envision for a moment that we have a set of vital servers in our environment that are managing large file transfers. And in that case, it's important for us to monitor the available disk space on each server, because if we go low on space, our application might fail and lead to an outage for our customers. So right now, the default collection interval for disk is 300 seconds, or every 5 minutes. And that really doesn't give us enough granularity to determine when the disks might start to fill up, and doesn't give us enough lead time to know if we're heading towards a problem. So let's go ahead and lower this collection interval, maybe to something like every 30 seconds. And hopefully that gives us the granularity we need to monitor our application. So I just included 30 here. Just scroll down and I'll hit save. And it looks like the change took. So let's go ahead and see what that did to our inputs.conf file on the file system. So here we are in the Splunk TA Nix app folder on our Splunk server. And if I look in the local directory, inputs.conf file, here's df, and you'll notice that a new field has been added, interval, with the number 30, indicating that df.sh will be collected every 30 seconds. So now from here, we're ready to deploy this app to our Linux hosts. But say we have hosts in our environment that don't require df to be collected every 30 seconds. How might we manage that? So when we copy this directory to our deployment apps folder on the deployment server, we can actually just give it a unique name. So let me show you the copy process. So copy Splunk TA Nix, that's this folder, to our deployment apps on our deployment server. And I just gave it a unique name by appending _disk to the end. So we'll go ahead and copy that to our deployment server. And now this way, we know that it's destined for a particular set of Linux hosts. And then from here, we can configure our deployment server, our server class, to target this particular app and our high disk space utilizing hosts only. All of the other Linux hosts can just get a regular copy of Splunk TA Nix. So those same collection strategies that we just went over can also be applied to other host types as well, whether they're provisioned as compute optimized hosts, memory optimized hosts, bandwidth optimized hosts, etc. We can increase or decrease the various collection intervals to best suit our needs. Okay, So that was a look at the inputs of the TA and how to find the collection interval that best matches the type of host we're collecting from. Next, we'll review how to search the data within Splunk. So let's take a look at searching our data. As a reminder, the source types of our various data inputs can be found on the Splunk add-on for Unix and Linux section of docs.splunk.com. So as a refresher from last time, let's take a look at some disk data. A good sanity check would be to look at our newly minted disk input. We recently changed the collection interval from 300 seconds to 30. So to get started, we know from the documentation that the source type we want is DF. So let's look at that now. Okay, good. So we're now looking at our disk data. We can see towards the end of our flash timeline that the number of events collected has started to increase. So this is telling us that adding the interval field to our inputs.conf to change the collection interval is working. So that's perfect. Also, as a reminder from last time, the TA can help us make sense of the data. From the raw data, it's not always obvious what every field represents. But if we use this arrow next to our raw event and drop into the event, we can see the fields that are available from the TA. I'm going to click the arrow, drop into the event. And here we can start to understand that the 74G from our raw data is actually indicating the available amount of disk space left on our host, and that the full size of this disk partition is 100 gigabytes. So we are going to be putting to use these automatic field extracts provided by the TA in our next example. Next, I'm going to walk you through a real-world example utilizing Splunk search and visualizations to create a high CPU alert. As I'm sure many of you have experienced, not every server will have the same monitoring requirements, especially when it comes to determining high CPU. It's no longer good enough just to create a static alert, something like CPU is greater than 90%, unless you really enjoy being inundated with false alarms. So today, I'm going to show you one way you can make it a little bit more intelligent. So we're going to start by determining average CPU consumption and create a baseline, and then use this baseline later to determine when our CPU is too high. But before we do anything, we need to know what fields to look at. So let's take a look at the CPU data found in source type equals CPU. Okay, good. So here's our CPU data. What we want to do is drill into this data using this arrow on the side to see what the field extracts are. So first we notice that CPU is all, meaning that this is an aggregation of all of the CPUs on our host. So we're going to want to use all. Let's add that keyword now. Next, we need to know which of these percent fields we want to use. So we have percent user, how much of the CPU is being used by user processes. We have percent system, so how much of the CPU is being used by the kernel. And then we have percent idle, so whatever is left over from the usage of user and system. So we're going to want to use idle. But what we're going to do is take 100 minus idle to actually get the total utilization. So let's create that field. Percent used is 100 minus percent idle. Okay, good. So now we have an idea of what fields we'll need to use to calculate our average CPU utilization. So next, I'm going to look at the average CPU consumption hour by hour. The reason we want to take an average hour by hour is because obviously overnight, nobody is going to be using my Splunk server, and hopefully CPU consumption should be lower during that time. And during the day, when I'm using the server, it should be higher on average. So it's important that our average calculation factors these in. So here's a search I made to grab the last 7 days CPU utilization averaged by the hour. Here's our search from before. Source type equals CPU, all keyword, and percent used is 100 minus percent idle. Then I extracted the date hour, and the date hour will then be used when we calculate the average percent used by the hour. And we're going to call this baseline. So here's the result. We can see that during the overnight hours, the Splunk server utilization is lower, and during the day, you start to see it's higher. During lunch, trails off a bit, and then starts to climb again until the evening starts and the Splunk server CPU starts to go down again. Okay, good. So that tracks. This is starting to look like a good baseline that we can use. But what we want to do is confirm that this baseline is a good indicator of when our CPU is too high. So to do so, I'm going to overlay the average CPU within the last day's worth of CPU data, and any time that the CPU usage is higher than this baseline, that's when we want to create an alert. So what we're going to do is start with the same base search that we had before. Source type equals CPU, all CPUs, percent used is 100 minus percent idle, and then we're going to make a time chart of the CPU, percent used, and call that CPU. Then what we're going to do is join that data to our baseline search. Now the only difference with this baseline search is that it's looking back the last 7 days using the Splunk reserved keywords earliest and latest. And now these two searches will be joined by the date hour field. Okay, so here's the results. The blue line indicates our live CPU, and the green line indicates our baseline that we saw before. Now this is looking really good. The only time we were going to get alerted here is when we have the CPU spike around 8:30 last night that lasted for about 20 minutes. And that's exactly what we want. This looks like a legitimate spike to me, and looks like there could have been a problem during this time. The rest of these ebbs and flows we can ignore. So now I want to pause and recap what we just did. So first, we searched our raw data using the CPU source type as our guide, and looked for the important fields in that data that could be useful later. We then searched the CPU data and came up with an hour-by-hour baseline. From there, we used visualizations to determine if the baseline was a good indication of high CPU. So next, we're going to create our alert. So now let's go ahead and click Save As from the top right and click Alert. Now we're presented with a ton of options to customize our alert. So let's step through those now. First, we want to give it a title and a description. I'm just going to call this one Robert's High CPU Alert. The description I'm going to say is Robert's Splunk server. Now permissions. I'm going to keep this private as it's an alert that's just for me. If I wanted to share it with the rest of my Splunk users, I could hit share in the app. I want this alert type to be scheduled, and I want it to run every minute. I'm not going to run it in real time because that would devote an entire CPU to this process. Now the time range. I'm not going to look back over the last 24 hours. Instead, I'm just going to look back over the last minute. And I'm going to let this expire in 5 minutes. I don't need it any more than 5 minutes because I don't need to save the old searches. Now, when do we trigger the alert? We want the alert to trigger anytime CPU is higher than our baseline. So we're going to select custom, and we're going to put in this box where CPU is greater than baseline. Now we're only going to trigger this once, but we do want to have it throttled, because if the CPU continues to stay high, I don't need to be reminded with the alert over and over again. So I'm going to say suppress triggering for 5 minutes. Now as far as actions go, Splunk comes preloaded with a bunch of actions. you can create a log event, you can output the results to a lookup, you can run a script, send an email. For the purposes of this demo, I'm just going to add this to my triggered alerts console. Set the severity to low. And with that, I've created my first alert. So I'm just going to hit save. And there we go. Now I'm going to be alerted anytime my CPU is higher than the average baseline. So with that, I hope you found today's webinar useful and have taken away how useful monitoring your Linux systems can be. If you're not using it already, I encourage you to go download the Splunk add-on for Unix and Linux and start turning your data into doing. So I'm going to turn it back over to Caitlin to share some additional resources with you. And thanks everyone for letting me share some details with you today about the Splunk add-on for Unix and Linux. I'll see you at the next webinar.
Great. Thank you so much, Robert, for that presentation and demo. So we're nearing the end of the talk, and I wanted to share a quick recap slide with some URLs that are relevant to things discussed in the talk. You're welcome to screenshot these, although they'll also be available in a follow-up email, which will have the recorded webinar. Finally, don't forget that we have an incredible community of Splunk users on our community site, where there's a Q&A section where you can search for NICs, discussions around IT Tech Talks, as well as Splunk ideas, where you can request enhancements to our solutions. If you want to learn more or continue the conversation, head on over there, and I'm sure you'll find what you're looking for. That's it for today. Thanks so much for joining us. We look forward to sharing more with you soon at our next Tech Talk.